problem based on the condition probability. Simple problems are there. See this question. A family has 2 children. Okay. What is the, you have to find the probability. What is the probability that both the children are boys? Okay. You are finding the probability that both the children are boys given that at least one of them is a boy. This is a condition. Is it clear? You are finding the probability that of the both the children are boys given one condition, that is at least one of them should be a boy. Is it clear? So you are finding the P of E by F. P of E by F. Here F is already occurred. Here occurred event is at least one should be boy. That is a condition is given. So F will be this one, E will be this one. Before that, we will write the sample space. Okay, we will represent boy as B and girl as G. So what is the sample space? What are the possibilities? Is 2 children are there. So that means one possibility is boy and boy, or boy and girl, right? Or girl and boy, or both the girls. This is a sample space, right? So this will be a sample space. What is the event E? Event E is nothing but both the children are boys. We will take event is both the children are boys. Is it clear? Event is both the children are boys. Now the set will be, now what is the set? E is equal to both the children are boys means only one possibility is there, right? That is B, B. So this will be now B and B. Is it clear? Now we will consider the event F as, what is the event F? At least one of them is a boy. At least one of them is boy. At least one of them is boy, or both are boys. That is also possible, right? So at least one of them boy means the F will be, what are the possible values? Boy and boy is possible, right? At least one or more than one is possible. So this is boy and boy is possible. Boy and girl is possible because one boy is there here, and another one girl and boy is possible, but girl and girl is not possible. So this is the probability of, this is the event here. Now can you say what is the probability of E? Probability of E will be equal to boy, probability of boy will be 1 by 2. Boy will be again 1 by 2. So 1 by 2 into 1 by 2 will be 1 by 4. Or we can observe here, this is only one element is there, and in the sample space 4 elements are there. So probability of E will be equal to 1 by 4. Now probability of F. What is the probability of F? If you want, you can write probability of F is equal to probability of boy, boy plus probability of boy, girl plus probability of girl, boy. Actually no need to write these things in exam, okay? Directly you can write. So this is probability of boy and boy. Probability of boy is 1 by 2. So this is also 1 by 2. So this will be 1 by 2 plus, and probability of B will be 1 by 2. G is, what is this? Probability of B is 1 by 2. B is also 1 by 2. So 1 by 4. And probability of here 1 by 2 into 1 by 2. This is also 1 by 2. That will be 1 by 4. Plus, and here 1 by 2 and 1 by 2. That is 1 by 4. That is equal to 3 by 4. Directly we can write probability of F is here 3 elements are there, right? And total elements here 4. It will be equal to 3 by 4. Now actually to find P of E by F, what is the formula? P of E by F is equal to P of E intersection F divided by P of F. So for this we need to find E intersection F. Intersection means common element. So E intersection F will be equal to, what is the common element in both? It is B, B. So we will write this B and B. So probability of E intersection F is equal to, that is 1, right? So this will be equal to 1 by 4. So finally substitute here P of E by F is equal to P of E intersection F is 1 by 4 divided by P of F will be equal to, P of F is 3 by 4. So 3 by 4, and here 4 and 4 will get cancelled, is equal to 1 by 3. So this is the final answer. That is the probability of, that will be the probability of both the children are boys at the condition at least one of them should be boy. Okay, that is 1 by 3. 10 cards numbered 1 to 10 are placed in a box. Okay, 1 to 10 numbered cards are there. Those are placed in a box, mixed up, and then one card is drawn randomly. Okay, one card is drawn randomly. It is given that if it is known that the number on the drawn card is more than 3, the number on the drawn card is more than 3, that is known one. Now what you have to find? What is the probability that it is an even number? Now you are finding the probability of that card should be even number, and given thing is the event already occurred is the number should be more than 3. Is it clear? I hope you understood the question. First we will consider, let E be the event. Let E be the event that drawn card is even. Drawn card is even. Is it clear? The drawn card is even, and what is given? The F be the event such that what is given? F the card should be, the number should be more than 3. The more than 3. The number should be more than, the drawn card number should be more than 3. Now what do you have to find? To find probability of an event E with respect to F, that is E by F. Okay. First let us define a sample space. Now what will be the sample space? Sample space is total 10 cards are there. What is the possibility here? Sample space will be either 1 is possible or 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this will be the sample space. What is the event E? Event E is equal to, now can you say what is the event E? Drawn card is even. Even means what are the possible numbers? 2 is possible, 4 is possible, 6, 8 and 10. So this is the event E. Now what is the event F? The drawn card should be more than 3. The number should be on the card, that number should be more than 3. More than 3 means it is possibilities are 4, 5, right? 6, 7, 8, 9, 10. Now what you have to find? P of E by F is equal to P of formula E intersection F divided by P of F. For that we need to find E intersection F. Let us find that E intersection F is equal to the common elements in both E and F will be 2 is not there, 4, 6, 8 and 10. Right? So numbers are 4, 6, 8 and 10. Now we got E intersection F, but we have to find the probability. So now what will be the probability of E intersection F? E intersection F is equal to, how many elements are there here? 1, 2, 3, 4. So this is 4. Total number of elements in the sample space is 10. So it will be equal to 4 by 10. Or I can write this as 2 by 5. Right? That is P of E intersection F. Next we need P of F. What is the probability of P of F? How many elements are there? How many possibilities? 1, 2, 3, 4, 5, 6, 7 possibilities are there. And total number of elements in the sample space will be 10. So 7 by 10. Right? Now we will substitute here. So P of E by F is equal to E intersection F is 2 by 5 divided by, that is 7 by 10. So this is 5 and 2. So this is equal to 2 into 2 by 7. So this is equal to 4 by 7. So probability of which one? What is given there? Probability of the number is even. Already it is given that occurred one is the number should be greater than 3 is 4 by 7. Look at this problem. A die is thrown 3 times. Okay, it is given the event A as 4 on the third throw, and B is given as 6 on the first throw and 5 on the second throw. Now you have to find the probability of A that B has already occurred. I mean you have to find the probability of A by B. Now can you say how many elements will be there in the sample space? The die is thrown 3 times. So total number of outcomes are there 6. Right? So it is thrown 3 times. It will be equal to 6 cube. Right? 6 cube is equal to 260. Is it clear? So the number of elements in the, we cannot list that. So directly we write number of elements in sample space. Elements in sample space is 260. Now can we list the first one? A is equal to, first one, see here, 4 on the third row. So 4 on the third row, 4 is fixed. Right here 4 is fixed. What are the possibilities? I can write 1, 1, 4 or 1, 2, 4, right, till 1, 6, 4. This is possible, right? This is the one possible. Another possibility I can write 2, 1, 4, right, 2, 2, 4 till we can write 2, 6, 4. Yes. Next will be, similarly we can write 3, 1, 4 or 3, 2, 4 or 3 till 6, 4. Right? Similarly we can write many. You have to write those 4, 1, 4, 4, 2, 4, then last 4, 6, 4. 5, 1, 4, 5, 2, 4, 5, 6, 4. Last one will be here 6, 1, 4, then 6, 2, 4, then the last will be 6, 6, 4. So these many elements are possible in the event A. With the event B, B is equal to 6 on the first row and 5 on the second row. So first and second is fixed, right? So it will be equal to 6 and 5 is fixed. So remaining elements 1 is possible, or 6, 5 and 2 is possible, or 6, 5, 3 is possible. Is it clear? First and the second row is fixed, only differs in the third row. That will be now 6, 5 and 4. Next 6, 5 and 5 or 6, 5 and 6. Right? But we need to find P of A by B. Right? For that we need A intersection B. Can you say what is the element A intersection B? How many elements will be there? Only one possible elements will be there. Here the last, value should be 4. Here only one last value 4 is there, right? So it is 6, 5, 4. Here it is there. Here it will be 6, 5, 4, right? Only one element will be there in the intersection, that is 6, 5 and 4. Now simply we can write P of A by B is equal to P of probability of A intersection B divided by probability of B. Is it clear? Probability of A intersection B. A intersection B is 1 out of 260 divided by P of B. How many elements are possible? Here 6 elements are there, right? Probability of B will be 6 divided by 260. So that I can cancel these two. So this is equal to 1 by 6. So this is the final answer. Okay? Carefully. A die is thrown twice. A die is thrown twice means what is the, how many elements will be in the sample space? Obviously 36, right? 6 square will be 36. Now next what is given? The sum of the numbers appearing is observed. Okay? The sum of the numbers appearing is observed to be 6. The sum of the numbers should be equal to 6. Now, what is the conditional probability that the number 4 has appeared at least once? Now, we are finding the conditional probability for this one. This is number 4 has appeared at least once. But I always take whatever the probability you have to find now, that you take as E. Another one you take as F, so that it will be easy. Okay. Now, E I will consider this is probability you have to find. See this one. What is the conditional probability that the number 4 appeared at least once? So this is the number 4 appeared. Is it clear? This is the event 4 appeared at least once. Clear? This is 4 appeared at least once. Now what are the possible elements will be there? 4 appeared at least once means starting will be 4 is possible. 4 1 is possible, right? 4 2, 4 and 3 is possible, 4 and 4 is possible, or 4 and 5 is possible, or 4 and 6 is possible. Other than this, 4 should appear at least once or more than once. More than once means 4 and 4. Other than this, we can write 1 and 4 is possible, right? 2 and 4 is possible, then 3 and 4 is possible. Anyway, no need to write this again. So this will be now 5 and 4 is possible. Next 6 and 4 is possible. These are the elements are possible, right? So that is the event E. Now what is the event EF? What is given? The sum of the numbers appearing is observed that to be 6. The sum of the numbers should be 6. What are the possibilities? If I consider 1, possible number should be 1 and 5 is possible, right? 1 and 5, the sum of the numbers will be equal to 6. 1 and 5 is possible. So obviously 5 and 1 is possible, right? Next I start with the 2. 2 and the number should be 4, right? 2 and 4. 2 plus 4 is equal to 6. Another one is 4 and 2. Next, another one 3 and 3, right? 3 plus 3 will be equal to 6. Now 4 and 2. Already we have it. 4 and 2. And next one 5 and 1. And this is 1 and 5. So these many elements are possible. Now you have to find P of E by F. First, for that we find the intersection E intersection F. What is the element E intersection F? 1 and 5 not there. 2 and 4 it is there, right? 2 and 4. Another one is 4 and 2. 2 elements are there, right? So I can write 2 and 4 and 4 and 2. These are the two possible elements. Now probability of E intersection F. Number of elements is 2. Here 2 are there. Divided by total number of elements in the sample space will be 36. So this is equal to 36. Now next probability of F we need, right? Probability of F, how many elements are there? 1, 2, 3, 4, 5, right? 3, 4, 5. So this will be now 5 divided by 36. What is the probability of E? Actually it is not necessary, but better you write. Probability of E will be 3, 4, 5, 6, 11, right? 11 are there. So this is equal to 11 by 36. Now we are finding P of E by F. P of E by F is equal to simple problems E intersection F divided by P of E. E intersection F is, what is that? 2 by 36 divided by F is 5 by 36. So that you can cancel 36 and 36. Answer will be 2 by 5. Okay. I hope you understood this. Let me read this question. Consider the experiment of tossing a coin. Try to understand this. Consider the experiment of tossing a coin. If the coin shows head, toss it again. Okay. If the coin shows head, then you have to toss the coin again. But if it shows tail, then throw a die. Is it clear? You have to toss a coin. If it shows head, you have to toss the coin again. If it shows tail, then you have to throw a die. Next, what is given? Find the conditional probability of the event that the die shows number greater than 4. Okay, you have to find the conditional probability of the die shows number greater than 4, given that there is at least one tail. One more given thing is given that there at least one tail will be there. First, let us write the sample space. Okay, sample space will be equal to, if you throw, you have to toss a coin. If it comes head, then I have to toss the coin again, right? If you toss the coin again, possibilities head and head is possible, right? So head and head is possible, or head and tail is possible. Is it clear? First, you have to toss the coin. If it comes head, then again you have to toss the coin. Then the possibilities head, head and head, tail. If it comes tail, then you have to throw a die. Then possible outcomes are T1 is possible, or T2, T3, T4, T5 and T6, right? Total how many elements are there? 8 elements are there in the sample space, because it includes both tossing a coin as well as throwing a die. Now we will write the events. Which conditional probability you have to find? Event E is, let me write this, the die shows number greater than 4. The die shows number greater than 4. Number greater than 4. Greater than 4. Okay. This is the event E. What is the event F? It is given that there is at least one tail. At least one tail. Is it clear? Now what you have to find? Probability of E with respect to F. We need to find P of E by F. Right? First we will write what is the event E. E is equal to, the die shows number greater than 4. What is the possible? The die shows number greater than 4 means 5 and 6. This is not possible, right? This is the coin toss. Here 1 to 4 is not possible. So it is given that the die shows number greater than 4. Possibility is now T5 is possible or T6 is possible. This is the only two possibilities are there for the event E. Now event F is equal to, can you say, at least one tail or more than that. At least one tail means here HT is possible, right? Then everything is possible, T1, T2, I hope you are getting this, T4, T5, T6, right? Now, what is the intersection of this? E intersection F will be equal to common elements T5 and T6. So, this is equal to T5, T6. So, clear? Now, we have to find P of E by F is equal to P of E intersection F divided by P of F. Now, we need to find the probability. Here is it. What is P of E intersection F? Probability is equal to, listen carefully, E intersection F is T5 and T6. It is nothing but probability of T5 plus probability of T6, right? Now what is the probability of T5? Now here we have to find the probability of T separately, then you have to find the probability of phi separately. This is a one, T and phi, right? This is one, T and phi, so we need to multiply, and here T and 6. What is the probability of T? It will be equal to 1 by 2, right? Head or tail, only two options will be there, so probability will be 1 by 2 into, what is the probability of phi? There are 6 possibilities are there, in that phi is only one possible value, right? So it will be equal to 1 by 6, is it clear? Tail is nothing but you are tossing a coin, so there are two possibilities will be there, in that tail will be 1 by 2. Phi means you are throwing a die, there 6 possibilities are there, in that 6 possibility phi will be 1 possibility, so this is 1 by 6, is it clear? Plus similarly here P of T will be 1 by 2 into 1 by 6, so this is equal to here 1 by 12 plus 1 by 12, is it clear? 1 by 12 plus 1 by 12 will be 2 by 2. This is the probability of E intersection. Now we will find the probability of F. So probability of F is equal to, everything you have to write, it will be probability of H and T plus probability of T and 1 plus probability of T and 2 till probability of T and 6. So clear? Listen carefully. Here what is the probability of H and T? What is the probability of H? H will be head, it is 1 by 2. Probability of T is also 1 by 2. So 1 by 2 into 1 by 2 will be 1 by 4. Right? So this is equal to 1 by 4 plus. Now probability of T and 1. Probability of tail will be 1 by 2. 1 is 1 by 6. So 1 by 2 into 1 by 6 will be 1 by 12. Is it clear? Probability of T is 1 by 2. Probability of 1 is 1 by 6. So it will be equal to 1 by 12. Similarly for everything, right? So it is 1 by 12, 1. This is second one, third, right? Fourth one, fifth one, and sixth. Now we will simplify this right here. Probability of F is equal to 1 by 4 plus here 1 is repeated 6 times, right? So 6 by 12. So I can write 1 by 4 plus 1 by 2. Take LCM. LCM will be here 4. So this is multiplied by 2. 1 plus 2 will be 3 by 4. Now just substitute here. P of E by F is equal to P of E intersection F divided by P of F. Now E intersection F is here, right? 2 by 12 I can write 1 by 6. So this is 1 by 6 divided by P of F. Probability of F will be equal to here 3 by 4. So we can write this is 2 and this will be 3. It goes up, this will be equal to 2 by 9. So this is the probability of an event E where F already occurred.